Hello, friends. I'm happy to share some thoughts on this interesting topic of quantum computing and emerging technologies to this August audience. Thanks for the organizers for having given me this opportunity. Now, when we talk of new technologies, what comes to our mind immediately are things like Internet of Things, big data, both of which pose problems into the area of privacy, artificial intelligence and machine learning, as well as the emerging area of quantum computing. Out of this, quantum computing is the one which is at the forefront of the future technology. So let us take that into some sort of a little bit of a detailed discussion. Now, to understand what are the cyber law implications of quantum computing, we need to first understand what is quantum computing and how does it differ from the computing which we know today, which we refer to as classical computing. Now, in classical computing, the processing is based on transistors working as gates that allow current to flow in one direction or stop it. Based on that, we can say the status of a particular data block is either 0 or 1. Now, using this principle and combining it with the binary language, we have identified a method by which we can use this representation of a data block and its status in terms of a charge, either 0 charge or some charge, as a representation of 0 and 1. And in binary language, we produce a sequence of zeros and ones and interpret it in the computer as equivalent to a data element of a alphabet or a number. And every set of data, which is zeros and ones, is also accompanied by a header information which gives an instruction to the computer of how to read this data. So the combination of zeros and ones in the body of the data and the header information together represent the data which law considers as evidence in many of the legal situations. So that is data representation in the classical computing. The same thing is used when a processor works in a classical computing. Now, quantum computing may still use binary representation of reading data in the form of the two alphabet language with zeros and ones, but the difference is that the data blocks used in quantum computing is they are not static like in the classical computing, but they are actually live subatomic particles like electrons or maybe a nuclei, and the subatomic particles keep spinning, and if they're spinning in clockwise or anti-clockwise direction will represent either the 0 or 1, which we then translate into the binary language. So that is the difference between the quantum computing and classical computing. And since the data states zeros and ones in quantum bits, which we call as qubits, is a little unstable, there are various technical issues which make it difficult for the quantum computers to be used in all scenarios where the classical computing is used. Now, in addition to this particular inherent state of instability of a qubit, because qubits work at near zero, absolute zero temperatures, and at room temperatures there is a problem. In addition to this instability issue, there are two distinct properties of qubits which create legal challenges. One is called superpositioning, another is called entanglement. Now, what is superpositioning? In a superpositioning, a qubit is expected to be in a data state, which in the classical computing we would expect it should be either 0 or 1. But in qubits, it can be either 0 or 1, both simultaneously. And the processing has to work on the basis of probability of a qubit being 0 and the probability of it being 1 at the same time. So probability becomes a sort of a parameter to be used in the processing. Well, technology people may use it and develop algorithms to process data within this probabilistic environment, but definitely the judiciary and the lawyers will find it a little difficult to understand how this uncertain status can be used for the purpose of processing. Therefore, what happens in an actual situation is that a classical computer is tagged along with a quantum computing element and we create a sort of a hybrid computer system where processing is done by the quantum element and the representation of data in the human interface is done by the classical computing. So the future of computers is as a hybrid computer using both quantum and classical computing together. So this is one of the important aspects of the emerging processing scenario. Now, the entanglement is another property where qubits exist in a status where there could be two qubits which are entangled, and when they are entangled, though they are separated by distance, they have a behavioral attachment in the sense that if the spin status of one of the qubits is altered from clockwise to anti-clockwise, the spin status of the other qubit automatically changes. So this is called the principle of entanglement. Now this also introduces a certain element of uncertainty into the data, and therefore in the legal scenario where we look at data as evidence, entanglement makes data a bit hazy. Okay, and therefore when a hybrid system processes an electronic data and presents it in a classical computer and it is presented as evidence in the court of law, the court need to understand and come to terms with this nature of processing which goes behind the scene and still appreciate it under the principles such as proving beyond reasonable doubt, etc., which people are accustomed to today. So this is one of the biggest challenges posed by quantum computers. The entanglement also raises some issues. The issue is that if data residing in one place can be remotely altered by changing the spin status in another location, the integrity of data as it lies in a computer which is under the lawful control of a person becomes completely unreliable. Now, if evidence is produced from a computer about which technically there is no possibility of complete control, then how will the law react to that is a point again which the classical judicial authorities need to come to terms with. Now, compared to these challenges of quantum computing, the challenges posed by artificial intelligence and machine learning are something which are simpler and maybe it fade to insignificance. The reason is you can always attribute the functioning of an artificial intelligence device to the person who created the program or the person who owns it, and therefore apply law as if it is the human being who used this AI device as a tool. There could be some nuances even here because artificial intelligence innate ability is created by the programmer, and that gets altered through the machine learning process where the original program could undergo some changes. So when an AI device makes a mistake, the question of fixing the responsibility either on the programmer or on the person who is in charge of the machine learning process needs to be determined, and probably that will be something which will be decided by the uh, classical judicial process without much of a problem. So therefore, I don't consider that as a big issue. But these emerging technologies really challenge the current concepts of classical judiciary and open out the cyber law scenario to cyber jurisprudence, who may not be judges today, who may not be quoting from the past judgments, but would be providing new concepts of techno-legal nature and demand that these concepts need to be recognized by the judiciary. And this is an exciting opportunity for people like us who revel in trying to bring technical principles into legal principles and try to create some kind of a new understanding. Maybe in a way it is disruptive to the current judicial thinking, but this is what we need to prepare for in the future. So, friends, this is in simple some of the thoughts which I wanted to share in respect of emerging technologies and how these challenges make it necessary for us to change our judicial thinking. Thank you.